Hi friends, and welcome to Dividing Fractions. Now I know it seems weird that we haven't done 4-7 yet, but bless the book's heart, it does all of the adding and subtracting of fractions, multiplying fractions, then throws in decimals, and then does dividing fractions. And I don't like that, so we are going to divide fractions first. So, just like yesterday, let's remember our rules for dividing positives and negatives. So we're going to remember, and writing these in the divide sign kind of looks silly, but it gets the point across. If you have a positive divided by a positive, the answer is positive. If you have a negative divided by a negative, our two negatives still come together, aww, and that makes a positive. And then if you have one of each, either negative on top is negative, and a negative on the bottom also gives us a negative. Okay, so we just have to, again, with like we did with the multiplication, you can just look at it before you do anything else and decide whether or not the answer is going to be positive or negative. Okay, now the key to dividing fractions, so to divide fractions, what I was always taught, it's a little bit different than what I think you, or different words, but it means the same thing. I memorized multiply by the reciprocal. Multiply by the reciprocal, okay? What you guys have probably learned is keep, change, flip. Okay, so you keep your first fraction, you change division to multiplication, that's the multiply, and the flip is the reciprocal. So instead of dividing, we're going to multiply by the reciprocal or keep, change, flip. And luckily again, we do not have to get common denominators, which just makes my life a lot easier. I don't know about you guys. So let's try a practice problem. Pretty simple. 3/4 divided by 1/2. 3/4 divided by 1/2. So keep, change, flip, or multiply by the reciprocal. We need to rewrite it, changing it to multiplication. So 3/4 times, and then we're going to flip that. So the denominator becomes the numerator, and the numerator becomes the denominator. Okay, so now this is what we have. I'm going to do a little pre-reducing because both the 2 and the 4 are divisible by 2. And multiply across. 3 times 1 is 3. 2 times 1 is 2. And then change that to mixed number. 2 goes into 3 one time with 1 left over. Okay, so really the big key is doing the keep, change, flip or the multiply by the reciprocal. And we'll try it again. This time we'll throw in some negatives. -4/5 divided by 8/9. Okay, so before we do anything else, we're going to keep, change, flip. Keep the first fraction. Change divide to multiply. And then flip the second one. It becomes 9/8. Okay? And here again, we could pre-reduce. You don't have to. We can just multiply right across, and then you can reduce. But I like to pre-reduce so we have smaller numbers. I can see 4 goes into 8, so I can divide both of those by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So don't lose your negative. A negative times a positive is negative. 1 times 9 is 9. 5 times 2 is 10. And we're done. That can't be simplified anymore. Okay? So again, the key, and if you were in class, it would make you recite this with me, either the keep, change, flip, or the multiply by the reciprocal. It'd probably make you say both of them. All right, here's another option. 1/3 divided by, ooh, this one's interesting, -5. Wait, what? But where's the second fraction? What do we do? Remember, when we have a whole number, we can write it as a fraction by putting it over 1. Okay, so that got sneaky for a second. Whew. So keep the first one, change divide to multiply. I'm just going to do it with the parenthesis. And if we flip this, it becomes -1/5. Okay, so again, the key there is making sure you write your whole number over 1 so we can flip it. Now I've got a positive times a negative, which is negative. 1 times 1 is 1. 3 times 5 is 15. And we're done. Not too bad at all. All right, number 4. -3/4 divided by -1.5. Uh-oh, now we've got mixed numbers. What are we going to do? Remember Sanford's rule for mixed numbers. Change them to improper fractions. So this one's going to have an extra step in there. First, I'm going to change it to an improper fraction. So I'm not doing the keep, change, flip yet. That all has stayed exactly the same. And -1/2 becomes 2 times 1 is 2 plus 1 is 3 halves. Now that it's written that way, I can do my keep, change, flip. So keep the first one, change divide to multiply, and flip the second one, and it's -2/3. Okay, so now I've got a negative times a negative, which is going to be positive. And notice, if you want, there's a lot of cross-canceling we could do. I'm going to do the multiplication the regular way first, and then I'll show the cross-simplifying. So 3 times 2 is 6, and 4 times 3 is 12. And 6 goes into 12. We can divide both of them by 6, which would give us 1/2. Now, if we did our pre-reducing, I've got a 3 on top and 3 on the bottom, and so those would both turn into 1s. And then I can divide the 2 and the 4 by 2. And you'll see that we have 1 times 1 is 1, and 2 times 1 is 2. All right, I hope this is feeling okay. We're going to do another one with some mixed numbers. The assignment on MathSpace has a lot of mixed numbers because MathSpace really likes its mixed numbers. And there you go. So this one is going to be 5 divided by -1 and 1/3. Okay? So we got a couple of changes we need to make. We got to make the first one a fraction, and we got to change the second one to be an improper fraction. So the 5 becomes 5/1. We're going to keep the divide for now. And we're going to do 3 times 1 is 3 plus 1 is 4/3. Okay? Now we're in a good position to do our keep, change, flip. So keep the first one. Change divide to multiply. I'm just going to use the parentheses. And flip the second one, and it's -3/4. And again, I just like keeping the negative in the top. The negative can really be in front of the whole fraction. It could go to the bottom. It doesn't matter. As long as there's 1 there, that's all we need. Okay, looking at this, I don't think there's any pre-reducing I can do. So I'm just going to multiply right across. 5 times 3 is -15, because we got the negative in there, and 1 times 4 is 4. Okay, 4 can go into 15. It can go into 12 3 times. 4 times 3 is 12. If we subtract 12 from the 15, oh, don't lose your negative, then that means we have 3 left over. So it's going to be 3/4. Okay? So that's what's happening there. Let's go over a story problem or two, though, so that you can see or hear what that looks like. The side pieces of a butterfly house are 8 1/4 inches long. How many side pieces can be cut from a board measuring 49 1/2 inches long? Okay, so the idea is we've got a board that is 49 1/2 inches long, and we want to cut out, or we want to divide that by 8 1/4 inches and see how many 8 1/4 can we get out of this 49 1/2. So it's going to be division, obviously, because we're in the division section. And we got two mixed numbers, so I need to change them to improper fractions. 2 times 49 is going to be 98 halves. Oh, plus the 1, so this becomes 99. Got a little excited there. Whew. 99 halves, and then keep the divide for now. 4 times 8 is 32, plus 1 is 33 fourths. Okay, now we're set to do our keep, change, flip. Keep the first fraction, change to multiplication, and flip the second one. Okay, or multiply by the reciprocal. Works both ways. Though multiply by a reciprocal actually is more generic. It will fit in more places than keep, change, flip, because you end up doing this concept quite a lot in algebra. Okay, I'm going to do some pre-reducing because I can tell that actually 33 goes into 99 3 times. I was going to go for 11, but then I was like, no, 3 also. So 33 goes into 99. So 33 turns into 1. 99 turns into 3. Already we've got much better numbers. And 2 and 4 are both divisible by 2, so that becomes a 1, and that becomes a 2. And all of a sudden, look at this. We've got 3 times 2, which is 6, and 1 times 1, which is 1. So really it's just 6. This means we can get 6 boards. And you can tell this problem was made specifically for this assignment because the number came out so evenly. In the real world, that wouldn't happen. You'd have extra one way or another. Okay. Do you want to do one more story? We'll do one more story problem. Okay, on Saturday, Lindsay walked 3.5 miles in 1 2/5 hours. What was her walking pace in miles per hour? Okay, so walking pace, miles per hour, means you're going to do the miles divided by the hours. Now I'm going to show you a little something. This is, we're going to get to complex fractions later on, like have a section with them. But for right now, I'm just going to show you the complex fractions exist. And we could actually write this, because remember, fractions are division, and this is a division problem. And so we could actually write this 3.5 divided by 1 2/5. Does that make you hurt a little bit? But fractions just mean division. So this just means 3.5 divided by 1 2/5. It's not really something to be afraid of. I'm going to rewrite this, though, in the regular sideways way, changing the fractions to improper fractions. So 2 times 3 is 6, plus 1 is 7, so 7 halves divided by 5 times 1 is 5, plus 2, 7 fifths. Okay, and now we will multiply by the reciprocal, keep the first one, change divide to multiply, and flip the second one. And look how conveniently that puts a 7 on top and 7 on the bottom, which means we can reduce those to 1, because 7 divided by 7 is 1. And if we multiply across, 1 times 5 is 5, 2 times 1 is 2, and then change that back to a mixed number. 2 goes into 5, 2 times with 1 left over. So she was walking 2.5 miles per hour. Ta-da! Story problems. Okay, good luck with multiplying or dividing fractions.